Welcome to Lesson 2 of Module 3, Radicals and Rational Exponents. So what are radicals and what are rational exponents? Well, a radical represents a root. For example, a square root or a cubed root, right? And a rational exponent is an exponent that's expressed as a fraction. And when we have an exponent expressed as a fraction, we can rewrite it as a radical. So for example, here, I give you two examples of radicals. We have the square root of 9, which is 3, and the cubed root of 8, which is 2. And I give you two examples of rational exponents, and they're more like rules. So x to the 1 over n, we can rewrite that as the nth root of x. And x to the m over n, we can rewrite that as the nth root of x to the mth power. Converting between forms is something that you might want to do in order to simplify a given expression. And you might actually go back and forth between forms in the process of simplifying, depending on what the question is asking. So if we want to go from radical form to exponent form, I want you to remember this rule. X to the m over n is the nth root of x to the mth power. So let's say that we have an expression in radical form and we want to convert this into exponent form. So we have the cubed root of x squared. We can rewrite that as x to the 2/3 power. Let's say we have an expression in exponent form. We can rewrite that in radical form, right? So we have x to the 4/5 power. In this case, m is 4 and n is 5. So we can rewrite that as the 5th root of x to the 4th power. Let's just practice simplifying some expressions. The square root of 49, you would just simplify that by taking the square root. 49 is a perfect square, and the square root of 49 is 7. The cubed root of 27 is 3. Now, these are just simple radicals that we're simplifying right now. If you don't know these by heart, just use the calculator. The beauty of this new digital SAT is that you can use the calculator for the entire math section. So if you don't know something or you just want to double check, use that calculator. Okay, let's take a look at this one now. So there are two things you can do here. I'm going to show you how to simplify this by converting forms. But again, you have a calculator. You can just substitute 8 for x and put this into the calculator. I'm just showing you for those who want to solve it algebraically. Maybe some of you don't like to use the calculator, then you should know how to convert forms to simplify. So we'll rewrite x to the 2/3 using this rule here. We have our x, which is 8, m is 2, and n is 3. So we'll rewrite this as 8 to the 2/3, right? Just substituting 8 for x. And like I said, right now, you can just put this into the calculator to get your answer, but I'm just showing you how to convert forms if that's what you want to do. So that's the same thing as the cubed root of 8 squared. Now the cubed root of 8 is 2, and 2 squared is 4. So that's how you would simplify this expression for the x value of 8. So here we have the properties of exponents. Believe it or not, you should have learned this in the 8th grade. Having taught high school, having taught 9th grade, I know that students come into high school and they say that they haven't learned this, but you should have learned the properties of exponents in the 8th grade. These are rules that will help you simplify expressions involving exponents. So the first one is the product rule. If you have x to the a times x to the b, you just add the exponents and you get x to the a plus b. So notice how in all of these rules, the base is the same, right? The base is x for all of them. If you have a different base, then you cannot apply these rules. So the second rule we have here is the quotient rule of exponents. X to the a over x to the b is x to the a minus b. So when you're dividing terms with the same base and different exponents, you keep the base, you keep your variable, and you subtract the exponents. Next, we have the power of a power rule. X to the a to the b power, that's just x to the a times b. So in this case, we're just multiplying the exponents. And then the last one, we have x to the negative a, right? When you have a negative exponent, that actually becomes the denominator, and we just put that under 1, right? So x to the negative a power is 1 over x to the a. This one, number 4, you do use a lot in simplifying longer expressions. So let's practice simplifying using the properties of exponents. So here we have x to the 3/2 times x to the 1/2. This is the product rule of exponents, right? We're going to use this rule here. X to the a times x to the b equals x to the a plus b. So we have to add the exponents, right? So this becomes x to the 3/2 plus x to the 1/2, which is just x squared. Let's try this one. X to the 2/3 to the 3rd power. So first, you should ask yourself, which rule are we using here? Well, this one is the power of a power rule, right? We're going to have to multiply the exponents. So this becomes x to the 2/3 times 3, which is x squared, right? 2/3 times 3 is 6 over 3, which is 2. That's how we got the exponent of 2 here. Let's take a look at this one. X to the 5 over 4 over x to the 3 over 4, right? This is a quotient. This is the quotient rule of exponents, the quotient property. Right, so we're going to subtract the exponents. So we can rewrite this expression as x to the 5 over 4 minus 3 over 4, which is x to the 2 over 4, which reduces to x to the 1/2. And now we can rewrite this, right? We're in exponent form. We can rewrite this in radical form as the square root of x. So if you guys are struggling with fractions, just because I know that for some reason everybody hates fractions, something must have happened to them in elementary school and middle school where everybody has all this fraction trauma. And if you are a victim of fraction trauma, just use the calculator, right? You can put fractions into the calculator. And what's really great about this digital SAT is that the platform that you guys are using, Blue Book, the calculator that you guys have is Desmos. And when we get to graphing, I'm going to show you how beautiful it actually is that you guys get to use Desmos. I mean, if you know how to use this calculator, it's really going to give you all the answers for this SAT. I'll definitely show you how to use it when we get to the graphing part, but you can put fractions into the calculator. You can put them on into your TI if you're using that as well, because you are allowed to use that on the SAT. just use them to simplify the fractions, to add and subtract fractions. If you don't like working with fractions, just use the fraction functions, okay? Use the calculator. Please pause this video and work on the Lesson 2 Level 1 problems in the workbook. So in Level 2, we're going to continue to simplify expressions with radicals and rational exponents. Here are the steps you need to take to simplify. You'll convert all radicals to rational exponents. That way, you can apply the exponent rules to simplify. And then you can convert back to radical form if needed, right? If needed, it depends on what the question wants you to do, and if it's multiple choice, what form your choices are expressed in, right? So convert back to radical form if needed. Use strategy to decide whether or not you should convert back or not. So let's take a look at this one. We have the square root of x to the 6th power. We'll rewrite this as x to the 6 over 2. 6 over 2 is 3, so that becomes x cubed. The cubed root of x to the 8th. Let's rewrite this as x to the 8 thirds. And I mean, that's really it. You can convert back to radical form as the cubed root of x to the 8th power. X to the 1/2 times x to the 3/4. We're going to use the product of powers rule. This becomes x to the 1/2 plus x to the 3/4. Again, like I said, if you don't want to add or subtract fractions by hand, just use the calculator and put in 1/2 plus 3 over 4. I'll show you how to do it by finding a common denominator, right? We can rewrite this as x to the 2 over 4 plus x to the 3 over 4, which becomes x to the 5 over 4. And now we can rewrite this in radical form as the 4th root of x to the 5th. Please pause this video and work on the Lesson 2 Level 2 problems in the workbook. In Level 3 of this lesson, we're going to work with solving equations with radicals and rational exponents. So let's take a look at a simple one here. We have the square root of x equals 5. So what we're going to do is we're going to use inverse operations and square both sides, right? So really what we're doing, and I only mention this because it's going to come up a little bit later in a future example. Remember, the square root of x is x to the 1/2 power. So what we're really doing is we're raising each side to the reciprocal power, okay? Because that's going to, you're going to want that to make sense when we have an exponent that is a fraction whose numerator is not 1, okay? So we're going to square both sides. The square root of x squared is just x, and 5 squared is 25. So here's what I was talking about. We have x to the 3/4 power equals 8. Using inverse operations, we want to raise both sides to the reciprocal power of 3 over 4. So that would be raising both sides to the 4/3 power, and we get x equals 16. The square root of the sum of x and 4 equals 6. So we'll square both sides. The square root of the sum of x and 4 squared is just the sum of x and 4. And 6 squared equals 36. So the square root of anything squared is just whatever's in that radical. So now we'll use inverse operations and subtract 4 on both sides, and we get x equals 32. So this lesson was just super procedural. Lesson 3 will be similar in that way. It's operations with polynomials. So it's really just about knowing the rules. And if you can use and manipulate that calculator, these questions should really be a breeze for you. No real world problems or word problems on any of these super procedural topics. So these are just skills that you need to practice. So that being said, please pause this video and work on the lesson 2, level 3 problems in the workbook. After you finish the problems in the workbook, you can stop this video and move on to the next one for lesson 3.